All right, number 3, CSEC ADMAT 2024, paper 2, exam video solution. All right, let's go. This question says, determine the point of intersection of this circle and this line. So that's a simultaneous equation. I'm going to substitute the line equation into the circle equation for the y values. Simple as that. We're going to get a quadratic, because a circle can be crossed by a line only twice. All right? So let's go. So when we do the substitution, so let's say sub line into circle. CIRCLE. All right, we're gonna get x squared plus, where the y is, I'm putting the x minus 6 squared, that's here, minus 4x plus 6y now becomes 6 times x minus 6 plus 8 equals 0. All right, let's expand these. X squared, expansion of this one is x squared minus 12x plus 36. That's the first term squared. That's twice product with 2. Multiply them and double it. Second term squared is that. Let's put a line to indicate that this is that. Then I'm going to come back to this 4x. Expand this into 6x minus 36. Let's shift this over a bit. Oh, we have space. 6x minus 36. That's what this becomes. Let's put a line there again. Show that expansion. 6x becomes this. And then I'm going to add a 8 equals 0. All right, the square term are these, 2 of them. So I'm going to get 2x squared. The terms in x are these 2, that's 10 minus 12. So 10 minus 12 is negative 2x. And the numbers, this 36 eliminates this negative 36. And so I only have this 8, that plus 8. Lovely. Divide through by 2, x squared minus x plus 4 equals 0. Wow. So this cannot be factorized. That cannot be factorized. Let's just make sure. So this is 10x minus 12 equals negative 2. 36, I mean it's negative 36, 8. Alright, cannot be factorized. So we have to use the quadratic formula on this. And we're already out of space, but it's going to be easy if I'm going to use a line. Find the other 2 points. Alright, I can make this smaller still. Zoom in and work. Let's make it smaller. Zoom in and work. Alright, let's zoom in here. So I'm going to use the quadratic formula to find the x here, which is x equals minus b, which becomes negative 1. Minus becomes a positive 1, I should say. Plus or minus the square root of the negative 1 squared becomes a 1. Minus 4 times a. What is stuff is cannot in there? What is happening here? What is happening here, Mr. Shaw? Something is wrong. Something is wrong. Oh, I made a mistake. This minus 4, change it to a plus 4. All right. Let's fix that. It's always good when you can find the mistakes. It's all a part of it. So this is supposed to be a minus 4. All right. Minus 4x. All right, let's go again. So we're going to have 2x squared here. And that's why I advise students to write with pens in the exam, and believe me. Because, I mean, anybody can make mistakes, right? And then in terms of the x's now, well, this and this now makes 2x, positive 2x. 2x minus 12 is now negative 10x. Different kettle of fish. Again, this 36 wipes out that negative 36 and now a positive 8 here. Equals 0. Divide 2 by 2, we get x squared minus 5x plus 4 equals 0. And now we're in business, but it's kind of factorized, which is what you would expect from a question like this. All right. Fortunately, we got one that could not be solved. Pathetic. But I would have tested the answers anyway in the end, so I would have found my mistake anyway. So that is it. So it's x and 1 and 4. This says the two signs are the same. This says they are both negative. Minus, minus. So getting x equals 1 or x equals 4. I'm going to substitute them in the line equation. So I'm just going to say, and using the line equation, y is equal to 1 minus 6. Or for this one, the y is going to be 4 minus 6. You substitute the 4 in the line equation there. Or when you substitute the 1 in the 4 equation there, you get this one. So we're getting y equals negative 5 for this one, and y equals negative 2. My solution is, this says determine the points of intersection. I'm going to write my solutions over here. All right, so that is 1, negative 5, solution. Let's zoom it up and write it, solution. 1, negative 5 is 1 point of intersection, and 4, negative 2. 4, negative 2. It's my second point of intersection. These are my answers right here. A and S for answers. All right, those are just simultaneous equations. This paper so far easy, except for that blunder on the question, the first question. All right, this question says, given that the coordinates of the points A and B are these 2 points A and B, they want us to state the portion vector of the corresponding points A and B in this form. Okay, so the portion vector is going to have the same values. All right, so we're going to write it like so. OA is a portion vector of A. You just have to state them, no calculation needed. And it's going to be 7I minus 3J. That's for this point. And then the B for that, which is the OB, it's going to be 2I plus 1J, which is just J. So 2 easy marks there. 3 marks actually. Then I want us to determine the vector AB. And the vector AB is equal to OB minus OA. Let's remind ourselves of what they are. So I can write these as column vectors to use them here. OB is the 2, 1, and OA as column vectors is a 7, negative 3. 7, negative 3. So if I were to just work as if I'm subtracting the values here, it is this one minus this one. So it will be 2 minus 5, 2 minus 7, which is negative 5. So that's going to become a negative 5I. And 1 minus a negative 3, because I'm doing OB minus OA. That's O times the last minus O times the first. So I'm going to be 1 minus a negative 3. That becomes positive 4. Minus is plus. So it's plus 4G. So that becomes our vector AB right there. Next part wants us to tell them the value of the scalar product of those two vectors. That's OA dot OB, scalar product. So let's go and work it out again. Very easy stuff. I'm going to copy these down. It's always easier to see what we're doing with the column vector form. So I just like to use it. Write them down. So let's put them here on the page in front of us. And we are doing scalar product is product of these two x values. And the first values are the I components. That's 7 times 2 is 14. I'm going to put the 7 times 2 for show of work. And negative 3 times 1. Negative 3. So we can say plus negative 3 times 1. Plus negative 3 times 1. So it becomes 14 minus 3, which is 11. Scalar product is 11. 14 minus 3. This question is so easy. And it's done. Oh my goodness. Oh my goodness. This paper is easy. Easy, easy, easy. This question says, using the letters P, Q, and R, write an expression for each of the following trig ratios. So this is the hypotenuse. This is the angle under consideration. That's the hypotenuse. That's the opposite. That's the adjacent. This is a CSEC level work. So this is the hypotenuse for the angle. Well, opposite the 90 is the hypotenuse. This is the adjacent. And this is the opposite to the angle. That's what we want to use. So the sine theta here, we know it's the opposite over the hypotenuse. And so we can write it here. Sine theta becomes the opposite, which is P, over the hypotenuse, which is Q. All right, let's leave these in red. Let's leave these in red. And then I want cos theta, which is adjacent over hypotenuse. So cos theta is the adjacent over the hypotenuse. And so if I want to rewrite it, it means that the cos theta, this is the adjacent R over the hypotenuse, which is Q, 3 marks. Then it says, using your answer in C1, determine the value of this, which you all know it has to be 1. All right? Recall that sine, this expression is the same as that. So I want the value of this. It has to be 1. Right? But using your answer, determine the value of that. All right. So I'm going to write that sine squared theta plus cos squared theta becomes equal to, now the sine squared means that we are squaring this one, the P over the Q. So it becomes P squared over Q squared plus, then this R over Q, square it, it becomes R squared over Q squared. So this all reduces to P squared plus R squared over Q squared. But Pythagoras' theorem, we have to get the one now. Pythagoras' theorem, so I think a lot of students might leave this as the answer, but you can't leave that as the answer, because the question said value. You have to get the 1. All right? So this numerator becomes the hypotenuse squared from Pythagoras' theorem at the end of the day, it's a right angle triangle. So you should know that Pythagoras' theorem says that q squared, or we can write it the other way, p squared plus r squared is equal to q squared. So this p squared plus q squared that we have on the bottom down here can replace with q squared. So that's how we're gonna get the 1, because this is q squared. So this then reduces to, let's shift this all over a bit. This becomes equal to q squared over q squared. Or we could have changed this q squared to these. Either way, same result, which becomes 1. So sine squared theta plus cos squared theta is 1. Right? Sine squared theta plus cos squared theta is 1. So I can write it here. Therefore, sine squared theta plus cos squared theta is equal to 1. That's what I wanted. Then we have this to prove that this is equal to that. First thing I'm going to do is write these tans as sine over cos. So remember that since tan of A is sine of A over cos of A, then this reciprocal, which is 1 over the tan of A, becomes the reciprocal of this, which is cos of A over sine of A. And these are what I'm going to use. So let's go back now. I'm leaving those on the paper, what I'm going to use. So the left-hand side, what space do we have? The left-hand side of this expression, the left-hand side is therefore equal to this plus this, which is the sum of these two things, which is sine of A over cos of A plus cos of A over sine of A. What do we do? We want the two denominators to become the same. We want the two denominators to be the same. Let me shift this up. So what I'm going to do, let's put the letters to show what I'm going to do in red. I'm going to multiply this fraction, numerator and denominator of this fraction, by this one. So I'm going to multiply this one by sine over sine. So multiply this fraction by sine A over sine A. Multiply the numerator by sine A and the denominator also by sine A. And then this one, I'm going to multiply the numerator and denominator by the cos here and here. This one, I'm going to multiply the numerator by cos A. I'm going to multiply the denominator also by cos A. So I'm showing what I'm multiplying by, right? Just to save some space. Right? That's what I'm going to multiplying by. And then when I do that, I'm going to get sine squared A from these two plus cos squared A from those two over the denominator becomes sine A cos A in both cases. Sine A cos A. And then the sine squared plus cos squared on there is 1. So this becomes 1 over sine of A cos of A, which is the right-hand side that they gave us here. That is the right-hand side. And this question is done. Easy paper. Alright? Easy paper. So let's continue. I'm wondering if I should show this another way. Let me show this another way. Let me just make this look better. Let me make this smaller first. Let's shift this around and make this better. Let's shift these around. So shift this away a bit. So generate the space. Right, that better. Alright, so let's write this better. I'm multiplying this one by sine A over cos A to show it. Sine A over sine A, I mean. So multiply this one by sine A over sine A, and I multiply this one by cos A over cos A. Should maybe put this in a different color. These that I'm using, put them in a box. Put them in a box. These are what I am using. Change the tans. That's it. That's better. That's better. All right. All right. See you in